Greetings, tech enthusiasts. Today, we're embarking on an epic exploration of roboforming, a groundbreaking technology that's not just transforming manufacturing, but reshaping the very fabric of our future. Get ready for a deep dive into the realm of innovation and possibilities. What is roboforming? At its core, roboforming is a mesmerizing symphony of technology. Imagine synchronized robots, each wielding a specialized sphere-tipped tool, delicately shaping metal and plastic sheets. This dance of precision and creativity unfolds without the constraints of traditional molds or dies. It's like sculpting the future with robotic finesse, bringing digital designs into tangible reality. Why was roboforming invented? To truly appreciate the significance of roboforming, we must understand the challenges that plague traditional manufacturing methods. In the not-so-distant past, creating intricate shapes out of metal or plastic involved the laborious use of molds and dies. These tools were not only expensive to produce, but also time-consuming, limiting the speed at which new designs could be brought to life. Moreover, traditional methods generated substantial waste, a concern in an age increasingly conscious of environmental impact. As the demand for more complex, customized products grew, the limitations of these techniques became glaringly evident. There was a pressing need for a manufacturing process that was not only cost-effective and efficient, but also sustainable. Enter roboforming. The very essence of roboforming lies in overcoming these challenges. It was invented to dismantle the barriers of traditional manufacturing, offering a dynamic and flexible alternative. By eliminating the dependence on molds and dies, roboforming drastically reduced production costs and lead times, making it a game-changer in the industry. Additionally, roboforming's minimal waste output marked a significant stride toward a more environmentally conscious manufacturing process. Its ability to shape materials incrementally without excessive material wastage not only saved resources, but also aligned with the global push for sustainable practices. Roboforming was conceived out of the necessity to unlock creativity, empower designers, and fuel innovation. It was not just an evolution in technology, but a revolution in the way we think about manufacturing. By providing a cost-effective, eco-friendly, and highly efficient solution, roboforming opened doors to a world of possibilities, enabling the creation of products that once seemed like distant dreams. In essence, roboforming was invented to liberate design thinking, to remove the constraints that hindered innovation, and to usher in an era where creativity could flourish without the shackles of traditional manufacturing limitations. Its creation was a pivotal moment in the history of manufacturing, setting the stage for a future where imagination knows no bounds. How will roboforming help humanity? Now, let's shift our focus to the profound ways in which roboforming is poised to shape the future of humanity. This technology isn't just about revolutionizing manufacturing, it's about empowering people, industries, and our collective potential. First and foremost, consider healthcare. Roboforming is paving the way for personalized medicine. Imagine a world where medical implants and prosthetics are not just functional, but perfectly tailored to an individual's unique anatomy. With roboforming, this dream becomes a reality. Customized medical devices, intricately designed and precisely crafted, enhance the quality of life for countless individuals, creating a future where disabilities are met with innovation and compassion. In the realm of aviation, roboforming is crafting the wings of the future. The aerospace industry is witnessing a transformation, with aircraft components becoming lighter, stronger, and more aerodynamic. This not only improves fuel efficiency, but also reduces carbon emissions, contributing significantly to the global fight against climate change. Roboforming, by enabling the creation of complex yet lightweight parts, is propelling us toward a greener, more sustainable future. Architecture, too, is experiencing a renaissance thanks to roboforming. Architects are no longer confined by the limitations of traditional construction methods. Bold, imaginative designs that once seemed unachievable are now within reach. Roboforming allows architects to bring their wildest visions to life, creating iconic buildings and structures that redefine skylines and inspire generations. Now, let's talk about high-performance vehicles. Roboforming is fueling the automotive industry's quest for excellence. From custom-shaped parts for supercars to intricate components for electric vehicles, roboforming is at the heart of innovation. By facilitating the production of lightweight, high-strength materials, it's driving advancements in both performance and safety, ensuring that the vehicles of tomorrow are not only faster, but also smarter and safer. Beyond these industries, roboforming is a driving force in the robotics revolution. Robotics, powered by precision engineering, are becoming integral to various sectors, from manufacturing to healthcare. Roboforming's ability to create intricate parts with unmatched accuracy is instrumental in the development of advanced robotic systems. These robots are poised to revolutionize tasks, from intricate surgeries to hazardous environment explorations, making our lives safer and more efficient. In essence, roboforming is more than a manufacturing process. It's a catalyst for progress. By enabling customization, enhancing efficiency, and fostering innovation, roboforming is shaping a future where our collective potential knows no bounds. It's a testament to human ingenuity, a tool that empowers us to dream bigger, design better, and create a world where technology serves humanity in unprecedented ways. What are the pros and cons of roboforming? First and foremost, versatility. Roboforming is incredibly versatile, capable of crafting a diverse array of shapes, from intricate geometries to double curvatures. This flexibility allows designers to unleash their creativity without the limitations of traditional molds and dies. Next, cost effectiveness. Unlike conventional methods, roboforming doesn't require expensive dies or molds. This translates into significant cost savings for manufacturers, making it an attractive choice for businesses aiming to optimize their production processes. Speed is another major advantage. Roboforming operates swiftly, producing parts in a single operation. This rapid pace not only boosts efficiency, but also ensures timely deliveries, a crucial factor in today's fast-paced industries. Let's talk about the environment. Roboforming generates minimal waste. Its precision-focused approach ensures that material usage is optimized, reducing the environmental footprint of manufacturing processes. In a world increasingly focused on sustainability, this is a significant pro. Cons. However, no innovation is without its challenges. One of the key concerns is the technology's relative newness. As a cutting-edge technique, there's ongoing research to ensure its long-term reliability. This uncertainty can pose a hurdle, especially for industries that require tried and tested methods. Showcase visuals of specialized equipment used in roboforming. Specialized equipment is another consideration. While roboforming eliminates the need for costly molds, the robots and tools used in the process are highly specialized. Acquiring and maintaining this equipment can be a significant investment, particularly for smaller manufacturers. Perfection, too, can be time-consuming. Achieving the desired accuracy sometimes demands multiple iterations. While the end results are impeccable, the iterative nature of the process can extend production timelines, which might not align with industries requiring rapid turnarounds. Moreover, skilled operators are essential. Operating and programming the intricate machinery demands a high level of expertise. Ensuring a workforce proficient in roboforming adds to the challenges, especially in regions where skilled labor is scarce. In conclusion, in essence, roboforming is a marvel of innovation, offering a gateway to a future where manufacturing is not just efficient, but also infinitely creative. While challenges exist, the advantages are transformative, pointing toward a future where intricate designs come to life with ease. It's a journey of continual refinement, where each challenge met becomes a stepping stone toward a manufacturing landscape that's both cutting-edge and sustainable. As we navigate these challenges, Roboforming stands as a testament to human ingenuity, propelling us into a future where the impossible is just another design waiting to be realized. And there you have it, the mesmerizing saga of Roboforming, a story of innovation, creativity, and endless potential. If you're as captivated by the future of manufacturing as I am, don't forget to hit that like button, subscribe for more awe-inspiring tech content, and remember, the future is unfolding before our very eyes. This is the AI Tech Underground, signing off. Stay techie, stay curious, and keep exploring the limitless horizons of technology.